Okay, so now we take everything that we've learned about solving systems and apply it to word problems, okay? Now, what's nice about these word problems is they are usually all in standard form. There's no slope-intercept form or point-slope form. So the main thing is setting it up and then solving using elimination. That's usually the go-to. We can talk about where substitution can be beneficial, but at the same time, elimination is usually the go-to there. So that being said, there are going to be three types of when you're setting up these systems of word problems. When we talked about this back in Unit 3, where it's literally given to you, this plus this equals this. You have also situations where it's item total, which they tell you how many of each item and then how many total items, and then cost total, where it tells you how much each item costs, and then of course the cost total. So first, looking into just the traditional word problems, like the old school ones, would be number 1 and 2. So it says the sum of two numbers is 30 and their difference is 12. Find the two numbers. So the sum meaning sum meaning add. So the sum of two numbers, which I don't know what the two numbers are, so we're going to use x and y. So I know that the sum of them, which means x plus y, equals 30. And then their difference, which means, again, I don't know what the values are, so x minus y equals 12. And they want me to find the two numbers. So right there, it's already set up for elimination because I can eliminate my y values based off being positive and negative. So remember, I treat it like one big addition problem. X plus x is 2x. My y's would essentially cancel. 30 plus 12 is 42. So when I solve for x, 42 divided by 2 is 21. Now, in order to find the second value, I plug that back into the original. So here, if I know x is 21, 21 plus y equals 30. And then to solve for y, I would just subtract 21. So y would end up being 9. And there are my two values. Now, how can I check this? Well, 21 plus 9 is 30, and 21 minus 9 is 12. So let's try another one of those. The difference between two numbers is 9. So again, I don't know what the two numbers are, so we're going to do x minus y equals 9. The first number, which we're going to assume is x, plus twice the other, which is y, 2y, is 27. So right here, there's two ways to go about this. I can choose to cancel or eliminate my x's, or I can eliminate my y's. Whichever route I choose kind of differs on how I would approach it. So for instance, if I want to eliminate my x's, I would need to change the signs of one of these equations. So if I choose to change the second one, it would be negative x plus negative 2y equals negative 27. So ultimately, I'm just trying to eliminate my x's. So the x's would eliminate. I would have negative 1y plus negative 2y, which would be negative 3y, equals 9 plus negative 27, which would be negative, that's 7, leave 3. I'm sorry, negative 12. And so y would end up being positive 4. So in order to find my x value, which means the second number, I would plug back 4 in for y. So x minus 4 equals 9. And so x would end up being 13. And if I checked it, 13 minus 4 is 9. And then 13 plus 8 is 27. So there's that. Okay, so that's the kind of different kinds of word problems. The ones that we normally see are what we're about to practice. So if we look at number 1, it says the cost of 3 boxes of envelopes and 4 boxes of notebook paper is $13.25. 2 boxes of envelopes and 6 boxes of notebook paper cost $17. Find the cost of each. So this is that example of literally given to me, where I know 3x, which we're going to represent x for envelopes, plus 4y, y being notebook paper, equals $13.25. Then I know 2 boxes of envelopes plus 6 boxes of notebook paper equals 17. So again, this is where we don't have the most user-friendly of numbers, but I can use it using elimination. Now, in order to do elimination here, I would actually need to multiply both equations by a value. So let's say I want to eliminate my x's. That means I want my x's to have a value of 6. Where the first one, I would multiply everything by 2. So 2 times 3x is 6x. 2 times 4y is 8y. And 2 times 13.25 would be 26.50. And then the second equation, I would want to get a value of 6, but I want to make it negative 6. So I'm going to multiply everything by negative 3. So negative 3 times 2x is negative 6x. Negative 3 times 6y is negative 18y. And negative 3 times 17 would be negative 51. So then I would cancel my x's out. 8 plus negative 18 is negative 10y. And 26.50 plus negative 51 would be negative 24.50. Now this isn't like what we saw last week where you're going to get nice whole numbers. Because we're talking about the cost, we can have decimal answers. So the cost of notebook paper, because that's what y is, would be negative 24.50 divided by negative 10. So the cost of notebook paper would be $2.45. And to find the value or the cost of the envelopes, remember I just plugged that back in. So this is where it gets a little dicey, more calculator involved for sure, just to help with the decimal values. Again, all I did was plug in $2.45 in for y, and then now I'm going to solve for x. So 1325 minus 9.80, then divide by 3. So the cost of envelopes would be $1.15. Now, the hardest part is knowing whether or not I got the right answer. So where you might want to check your answer is plugging both of these values into one of the equations in your home screen. So for instance, like 3, I know it's $1.15 plus 4 times $2.45. I want it to equal that right value. So that's how I kind of check it. Okay, so let's practice some more. The cost of 12 oranges and 7 apples is $5.36. Again, we're going to do oranges as x and apples as y. And then 8 oranges and 5 apples cost $3.68. And we want to find the cost of each. So again, this is where I have to multiply both values. It's not so much, it's just kind of preference for me. I guess I would multiply the y's. So in order to eliminate the y's, I would multiply the first equation by 5 and the second equation by negative 7. So then just calculator more involved here would be 60x plus 35y equals 2680. And then the second equation would be negative 56x minus 35y equals negative 25.76. And so then every process is the same. Here would be 4x. My y's would essentially eliminate. And then 2680 minus 2576 would be 0.04 and $1. And so let me make sure because I have made mistakes. Okay, divide by 4. So the cost of, let's see, we found x. So the cost of oranges would be 26 each. And then to find the cost of apples, I would then plug that back into the original. So 12 times 0.26 would be 312. Again, this is no different than what we've been doing. It's just the numbers are not the most user-friendly. So calculators definitely come in handy for this part. The process is the same. So the cost of apples to find y would be 32 cents. Now again, to check my answer, I would take my original, plug in the x and the y that we found, and then I should get the same dollar value. Okay, so let's do that again. It says one night at a theater sold 548 movie tickets. Adult tickets cost $6.50 and a child's ticket cost $3.50. In all, 2,881 was taken. So this is that example of not given to me, but item total, cost total. So item total would be an adult ticket plus a child's ticket. I know there were 548 total sold. So that's item total. The cost total would be 650x plus 350y equals 2,881. Now you first look at it, looks daunting, right? You're like, how am I going to use elimination? Now this could definitely be a substitution, and I can make a separate video to show that, but I'm going to continue the process of elimination. So by elimination, all I have to do again is have my x's or my y's eliminate, which essentially here just kind of depends on preference. I want to eliminate my y's. So I'm going to multiply that first equation by negative 3.5. So I have negative 3.5x. I'm actually going to do it down here. Plus or minus 3.50y, which that's the purpose of it, is to eliminate the y's. But then 548 times negative 3.50 is negative 119.18. And then so my y's cancel. 650 minus 350 would be 3x. and then equals 2,881 minus 1918 is 963. So X is 321. That means there were 321 adult tickets sold. And to find the number Y, or child tickets, I would plug it back in here, which means it's just 548 minus 321, which is 227 child tickets. Okay, so again, if I lost you on that one, rewatch it in slow motion. If I look at number 4, adult tickets were sold for $350 each, student tickets for $250 each, but there were 321 tickets sold for $937.50. So again, this is that item total, cost total. Adult tickets would be X, student tickets would be Y, and then since I know there were 321 tickets sold, that's item total. Cost total would be 350X plus 250Y equals 937.50. And again, this is like one of those, I can show you how to do substitution, and I'll put that in another video, but otherwise this is just elimination. Again, totally up to preference. If I want to eliminate my x's this time, I would multiply everything by negative 3.50, ironically the same as the last one, but it would be negative 3.50x minus 3.50y equals negative 1,123.50. And again, eliminating the x's, the y's would be negative 1y equals just to be accurate, negative 186. But y, when I divide by negative, would be 186 tickets. Again, the y represents the students, so that's 186. To figure out how many adult tickets, I would just subtract 321 minus that. So it's 135 adult tickets. And there it is. Okay, last but not least, at least another type that we see is one that's a little deceptive because it doesn't flat out tell me what it is. All it says is there's a collection of dimes and nickels, which is worth $3.30, and that there are a total of 42 coins in all. This is an example of item total, cost total. So I don't know how many dimes, so we're going to use X, plus I don't know how many nickels, which is Y, but I know there are 42 of them. But you're like, well, how do I write that second equation? Well, this is why you have to know the value of those. A dime is worth 10 cents, so 0.10x, and a nickel is worth 0.05y. And since I know the cost total would be $3.30. Again, this is just up to preference. If I want to eliminate the y's, I'm going to multiply this one by negative 0.05. So I have negative 0.05x minus 0.05y equals negative $2.10. And then I eliminate, so this would be positive 0.05x. My y's would essentially cancel, and 330 minus 210 would be $1.20. So the number of dimes I have would be 24. And you want to get a whole number there because we're talking about a physical number of objects. So then to find the number of nickels, I would just do 42 minus 24. So there's 18 nickels total. Okay, so again, I'll play another video of how to approach these with substitution. A little more tricky, but not too difficult.